Hello everybody, this is Mr. Cousage again, and we are up to lesson 6-3. We'll be solving linear systems. Well, we already solved linear systems, right? We're using matrices and row operations. Remember that? Okay, well, we want to look at two new ways of solving linear systems. Okay. One way is by using the inverse. Now, obviously, if you're going to use the inverse, you have to know what inverse means and how to get the inverse of any matrix. So what this rule says, what this method says is, if you have a matrix and variables equals another matrix, then all you, if you want to find the variables, what they're equal to, all you do is figure out the inverse of this matrix here, then bring it over here and multiply it to this, and you're done. Right? So you got to know how to, we did this yesterday, how to find the inverse of a matrix. Okay, we did this yesterday. It has to do something with the determinant. The determinant. Do you remember that? Okay, here we go. So here's my linear system. I want to solve this. So let me set it up, and it's going to look a little bit different. A little bit the same and a little bit different. So just like before, we drop the letters and keep the numbers for this matrix, and we only have x and y right there. And then on the other side, we make a separate, right, for the equal sign, we make a separate matrix. So this is my A matrix, this is my B matrix. So how do I solve this again? Well, we figure out what the inverse of this matrix is, bring it over here and multiply with this matrix. And I'll have the answers for x, y. I'll have the answers. So let's step aside and find the inverse of this. How do you do that? Well, if you look back to yesterday, to 6-2, the way we do it is 1 over the determinant times the A matrix switched around the numbers and the signs. Okay, look back to 6-2. So what is the determinant? That's when you cross multiply like this and subtract the answers. So the determinant goes down here. And what do we do with the matrix? We switch these two, right? 2, 5 become 5, 2. Leave these alone, but change the signs. So negative, negative become positive, positive. So what is my inverse? Well, that's going to be 1 over 1. That's kind of easy. 1 over 1 is 1, and then you multiply everything in here. So 1 times everything in here keeps it the same. So there's my inverse. I found my inverse. The inverse of the A matrix, the first matrix here. Now what? Well, according to the method, I bring my inverse to the other side and multiply with what's there, the B matrix. Right? So doesn't it look like this? Okay, I'm going to hide the answers. So that's it. Now, I multiply these two and I'll be done. So do you remember how we multiply? Boom, boom, add, boom, boom, add those answers, right? Multiply, multiply, add the answers, multiply, multiply, add the answers. So you get negative 5 plus 9, right? Negative 3 plus 6. That's where I write it down. I wrote it down here. Negative 5 plus 9 is 4. Negative 3 plus 6 is 3. That's it. So xy corresponds to, I'm sorry. Right? Negative 5 and 9 is 4. Negative 3 and 6 is 3. That's it. So xy corresponds to 4, 3. So x must be 4, y is 3. There's a couple of different ways of writing it. You can leave it like that. Don't leave it like this. You can leave it like that, or you can put it in parentheses like that. 4, 3. xy, 4, 3. Okay? That is one way to solve a linear system, right? You need the inverse. You need the inverse. The inverse of this gets multiplied by the other side. Excuse me. Here's another way. There's another way of doing it. This other way is called using Cramer's rule. Okay, what is Cramer's rule, right? Using Cramer's rule. Well, Cramer's rule says if you set it up like before, then here they call it x1, x2, but it could be xy. Your first variable is equal to a sub 1 over a. Now notice these bars mean determinant. So the determinant of a sub 1 over determinant of a. Well, we already have a. The other variable is equal to the determinant of a sub 2 over determinant of a. Right? So the determinant of a is easy. You just do that cross multiplying and subtracting. Where's a sub 1 and a sub 2? Where do you get those? A with a sub number, which we'll call I, is the matrix with the ith column is replaced by the B matrix. Wow, that is confusing. Not really. When you see it, it's not. So I is just a counter. So if you want A1 or A2 or A3 or A4, you do something to the first column or the second column or the third column or the fourth column of the B matrix. So, I'm sorry, you do something with the column, with the B matrix that you place in the A matrix. Anyway, I think you'll see it when I do the example. So what is the A matrix here? That would be the 3, 2, negative 4, negative 1, right? And this is the B matrix, right? So now how do we get A1 and A2? So what we're going to do is take the A matrix and replace, for A1, replace the first column. For A2, replace the second column. Okay, replace it with what? Replace it with B. So look what I did. Here's A. If you take this column out and replace it with B, don't you get this? Right? I replaced the first column with 6, negative 13 with B. And there it is. Now, how do you get A2? You do the same thing, except you replace the second column. So take out the second column and put 6, negative 13. There you go. So I got A1, A2. Now, I do this with them. Right? The determinants of A1 over the determinant of A. Determinant of A2 over determinant of A. So we need the determinant of all three of these, which is easy, right? Cross multiply, subtract. Cross multiply, subtract. Look back at 6, 2 to find out how to do the determinant. So for x1, it's going to be determinant of A1 over determinant of determinant of A1 over the determinant of A. So what is the determinant of A1? That would be 3 times negative 1, 2 times negative 4, and subtract. Right? So A goes in the bottom. Okay, let me hide the answers. Now I do, according to the rule up here, right? For the top, I do the determinant of A1. Right? So let me do the determinant of A1. 6 times negative 1, 2 times negative 13. There it is. And I get these answers. And 20 over 5, which equals 4. Done. Right? So I solved for x1. x1 is equal to 4. Now what is x2? Well, x2 is equal to the determinant of A2. So that would be 3 times negative 13, 6 times negative 4. Right there. And the determinant of A, which we already did, we know it's 5. I'm writing it down, but you can just borrow from here. It's 5, right? So it comes out to that, 15 over 5, negative 3. So I found x1. So x1 is 4. x1 is 4, and x2 is negative 3. I found the two variables. Okay? So this is what you put in the box. So it's A1 over A. It's all determinants, determinant of A1 over A. Then for the next variable, determinant of A2 over determinant of A. Right? And that's it. This is another way of solving linear systems. Okay? That's it for 6.3. I'll see you in I'll see you for 6.2. I'm sorry, 6.3 part 2. Okay.